Hello, this is Gary Fox, and we are going to do another tangent from two circles. This time we're going to do it cross. And on the manual part of it, showing it to you on CAD, I'm going to do things a little bit different because there's a lot to show here, and I want to show you more of general principles than I do the specifics. When we get into drawing the actual manual one, you'll see all the specifics anyhow. This is my third iteration on this thing, and as you can see, I've named things over here so I can remember the steps I was wanting to go through. Anyhow, to do it with the simple method with CAD, it's straightforward. It's built right in the program. There is one little trick. So we'll do from circle to circle a tangent, and we're going to start on this side on this circle, and then we go up to the opposite side. The little trick is, if you watch out, it'll do funny things on you. So you have to be kind of in the general area of where you want to be. So we'll click that, and we have our first cross built. And if I want to do it on the opposite side, I do the same thing. And that's it. That's all there was to it. Simple. Duh. Easy. Okay. So we'll delete those two. And now I go into the talk of the general principles. Okay. In the last time, you remember that what I did was I took the circle here and I drew it up on the a radial, and that gave me an inner circle. And then basically a smaller circle. And basically what I did was I used our procedure to go from tangent, to draw a tangent to a circle by going through the middle to the point that was in the middle of the small circle. So we did it big circle minus little circle to come up with this small circle here that we used to draw our tangent to the center. And when I did, I first drew this line right here to know where the tangent would go. That's where this circle crosses. And then I drew that tangent. Then all I did was offset it by drawing it up here to the outer edge of our big circle. And then that gave us, when I said last time, a trapezoid. It's actually a parallelogram, but it's even more specifically a rectangle that it forms here because it's parallel on both sides, but both of them are at right angles to each other. So that's how we did it last time. This one's going to work very similar. So what I will do is I draw a big circle, and let's get rid of the same side tangents right now. And then what we will do is that we do a let's see, yep. Basically, I took that same circle and I drew a tangent line here. I had to go all the way out to this big circle because what we did, we added the, let's go back one step. We add the radius of the small one to the radius of the big one to come up with this really big circle. Then what we have to do is find a tangent from that circle to the point, the center point. And that's what I did. Then it was necessary to draw this line here again because I'm going to have to copy it to figure out where the landing point is on this side right here. And then I copy this tangent from the center to this big circle. I just offset it, and that way I got a tangent to the small circle. To this big circle, I guess, biggin's what we called it last time, to the small circle. Hard to explain, but you can kind of see what I did. I basically did a parallel and made this down here. Be lucky if I can get through this on the when I do it manually. Anyhow, so let's turn all that off, and let's zoom out one thing. Why is all this kind of nice to know? Well, In the aluminum mill, when I worked there, we had all these different rolls that served different purposes, and the metal rolled around those rolls. And we often had to draw a pass line to figure out some things about it. So if I draw the pass line here, and it's actually the easiest way to do it was CAD. The calculations kind of got old in a hurry. And the metal would go around these big rolls here, and what those rolls are called bridle rolls. And what they do is they're either pulling or holding back on the metal, and they got big motors on them or brakes. And the ideal is to change the tension of the sheet at this point to this point right here. And so it was really important to have what we called a big wrap angle, which is the tangent point to the tangent point. We would measure the angle between those, and that would give us an idea of how much tension we could increase on each roll. And then usually the metal, we wanted to have a big wrap angle, so we had to have the metal heading downward in this case, but often the line was on out here wanting to go upward, so we'd have to rotate around all the way around this coil, this roll, and then I go back to a pass line that was at a high level. Maybe it was going across tanks, maybe, and then later on it would come back through at a lower point. All depend on how the line was laid out, but it was necessary to come up with these numbers to have an idea of how much tension we could pull on these rolls, and then also what was the tension at this point right in here. So this is good stuff. If you think about it, another case where this belt that I'm showing here, or this was sheet of metal, but it could also be a belt, and if you think about this winding around, only it would go back around and then eventually over to another roll that would come back to this belt. It's exactly what you got in your car if you got a serpentine belt that runs all of the accessory items like your alternator, which is a pretty important accessory, and your power steering pump and your air conditioner compressor. If it runs it all off of one belt, this is kind of the way the belt gets laid out around there to figure out how to route the belt. So as you can see, this is kind of a useful technique that we're learning right now. And I hate to be teaching stuff that you'll never have a need for. So now we'll go and do it the manual method, and I'll go into details of what I did with steps. I think it was step 2. Yeah, this one here, and the add radius, and then the cross tangent that we did right here. I'll show you how that's done manually, and we'll go through all of the boring details in the video where I do it over my shoulder. And this time I hope I get lighting better. Can't get any worse than it was last time. Appreciate you listening. I'll be back here on the flip side. See ya. Hi, it's Gary Fox, and we're back for the second half of this thing. And what we're going to do is draw the tangent, but we're going to cross it. And may have a little better straight edge. This time I'm not trying to do it with some extra lighting. I think we'll be better off with this diffuse lighting that I have. So first we'll draw this line right here between the two centers, only I missed a point. Let's see if we can do it again. That looks a little bit better. Remember, it'll be the top line. Okay, first thing I need to do besides that is I need to draw a radial line. So we'll draw one, we'll draw it a little bit off to the side. And the compass is already set to the radius of the little one. So now we'll do it to the we'll calculate what we need, and we're only going to draw just the top half of it because
we're having to add, so there's no reason to draw the bottom one. Looks like I missed my point. I gotta be a little more accurate here. Okay, now we have that. So now it's time to draw the great big old circle, or at least a big portion of it. So we have to find this and get it set to the right place, and I believe I'm there. So now I will draw that circle. And we'll draw it all the way around. We might decide to do both of those tangents. Okay, now we are ready to find the midpoint of this line between the two circles. If I can find my hole right there, I think I'm in it. And that should be more than half the distance. We'll draw it a little bit bigger. We'll draw an arc up here, an arc down here. We're bisecting the line right now. Previous video in case you missed it. Okay, and now we have to find the center. So we will use a straight edge between those two cross points. And I'll use this side of the straight edge to avoid the shadow. Because the shadow knows. Nah, the shadow don't know. It's not a problem. So there's our midpoint. So now we will draw an arc from here, the center of this one, until it crosses that big circle. And we'll go ahead and draw it in this direction. We may decide to go that way too. Okay. Now we will draw a line between the center point to where that one crosses, and that is our perpendicular to the tangent, and the tangent being the tangent that goes to the center of this circle. So we're going to draw that tangent. Now all we have to do is draw a parallel to that. Use the side of this thing, I think it's the best. By the way, on my website, and I will have a link to it, I have a new web page. It's called Tools, and there I have a bunch of Amazon links to drafting tools, and so you can see what the good triangles look like, and then also what a good compass would look like. Not this cheap stuff that I'm using, but as I said in an earlier video, this cheap stuff is good enough to show you the concepts. So now we have a tangent. So I got a little bit of a wiggly line there, but let's try it this way. By having a thicker straight edge than one I had before, and one that doesn't have a bevel. This one is square on the edge, whereas the one I was using before, and I just hit my tripod, but hopefully it's okay. The one I had before was beveled, and that kind of sucked because this thing kept wanting to ride up over it. And so now I have a tangent that goes from my original circle and is tangent to the opposite side of the other circle. So we got to accomplish what we wanted to do. If we were wanting to do it to the other side, of this circle, we would have to go to this crossover point. And then we would draw from here to the center point of that circle. And then I would offset to get down here. I'm not sure I'm going to do that right now. If you notice, if I went to the original tangent point, which should be about right there on this first one, I have a rectangle. And last time in the last video I said that was a trapezoid. I was wrong. It's a parallelogram, but it's specifically a parallelogram with right angles. That makes it a rectangle. Okay, anyhow, I think we got it. And between this and what I did in CAD, I think you got the idea. Appreciate you watching. Hopefully you got something out of this. So Gary Fox of Create Make.